Good evening and welcome to Tinkering with Edkelar. Ready for another little tangent? This time I'll venture out into telephony for a bit. It's a smaller project, so I got a 2-for-1 episode. To complement my collection of various tech stuff, classic telephony stuff was still missing. You know, the mysterious landline thing of the ancient days of yore. The biggest issue with these devices is their dependence on some sort of central office. They won't do anything on their own. You need at least some sort of machinery to make them go. And that can still be quite expensive, not to mention bulky. Thanks to a video by Cathode Ray Dude, I finally found a suitable device to get going with my small set of phones. A Teltone telephone line simulator, model number TLS-5. Let's dig into it. First off, the case seems a bit worn. At least the instruction label on top is peeling off around the edges. Opening up the device reveals not one, not two, but 3 PCB-mounted transformers. Yikes! Getting started with the usual disassembly and cleanup procedure. The mechanical part is quite simple. Apart from a small daughter board on top and a power socket, everything else is on a single PCB. Based on various labels and date codes, the unit seems to be made around 2006. I'll still set out for a recapping, mostly because I have no idea what the previous storage and/or operating conditions were. The transformers also have to be updated or modded. I'd like to run this on our 240 volt system. Foiled! Somebody thought it would be a good idea to weld the cores shut. Sure, less vibrations and such, but how am I going to rewind the primary coil now? Time to fire up the search engines. I managed to find suitable replacement transformers. They are small enough to fit into the original positions, but sadly not a single one has the same footprint. I have to improvise a bit. Recapping was also a bit of an issue. There's 2 larger electrolytics and the replacements I got are decent, but much too tall for the enclosure. Whoops! I had to mount them across the board instead. The lower voltage one wasn't a problem. There's a plot of resistors next to it and it can rest on top of them. But the second one didn't have a good way to put it flat against the board. There are higher power or even heat-sinked components all around. And since this cap is clearly carrying the DC voltage for the ring generator, which tops out at 90 volts, I didn't want to put it too close to a heat source. So, creative angle it is. I might order a better fitting one with my next capacitor order, but for now, this will do. I did check up on the two original caps with the LCR meter. The lower voltage one was fine, about 337 microfarad of the rated 330, but the higher voltage one, only about 86 of 100. That is a smidge too low for my taste. Soldering the transformers into place took a bit of extra wiring. The two larger ones originally were also bolted to the PCB for mechanical rigidity. My replacements didn't quite fit, so I have to rely on the solder joints for one and a few zip ties for the other. Doing a quick sanity check, feeding in about 20 volt AC and measuring the output of the transformers. Plausible. And after giving the case a good clean and peeling off that nasty looking sticker, I put the PCB into the case again. And of course, double the line voltage means half the amps. So I replaced the fuse with a lower rated one and give it a try. Nothing? Oh, the fuse is blown? Might be because I used a fast blow type. Looking for a suitable slow blow one and repeat. Including the blown fuse. This turned out to be quite a bit of a mess, to be honest. Now, I could gloss over my mistakes and remove them in the edit, but I think it's better to share. A few tries later. Where was the problem? Well, if it only were one. First off, I discovered that I misinterpreted the primary and secondary side of the third transformer. At 120 volts output and testing it at a low input voltage, I think that's a reasonable mistake to make. I had to flip it around again and resolder all the improvised pins. Now the second mistake was that little red disc. I saw that it tied into the primary side of the power supply, but I didn't quite follow the traces or looked at it too closely. With 3 transformers in parallel, I thought it was a PTC of sorts to do some inrush limiting, but it turns out that it was in parallel with the transformers, that is, smack across the input line. A MOF, that is a varistor, intended to protect against overvoltage, and this one is a 150 volt model. Trying to run the device on 240 volt without changing that one was futile. Many fuses gave their life. Also, this might have saved the circuit from the wrong transformer installation. So until the ordered replacement arrives, I'll just trust my mains line and run that thing without it. Contact! Yes! No! Yes! No! What's going on? The power LED is flashing low-high signals. I thought there might be something broken, but it turns out that this is the all good and running signal. Telephony stuff is really weird. So, testing? Since I didn't restore any of the phones in my collection yet, I had to pick one for the test. This model here is a bog standard you got a phone now model that the Austrian phone company dropped off during the 1990s. I cut off the old plug and replace it with a temporary one. Click. Yes! Dial tone, and it also rings. I remade the sticker in Inkscape. A bit of double-sided tape and glossy photo paper makes for an almost factory new look. Now to the phone. It certainly needs a bit of cleanup. One of the screws in the base is covered with a plastic plug. This is a remnant of the old "only authorized equipment is allowed on our phone lines" days, since there used to be a seal stuck on there. Well, not on this one, but in general. On the inside, we can see that the phone's main PCB looks very dated. It is indeed the same one as the rotary dial model had, mostly because this has been tested by the phone company and was certified as a line terminating component. The vendor didn't want to certify each modification all over again, so they just tucked things onto it instead. There's a bit of paper in here to show different connection schemes for the various line box options we had around the country. Also note that the cable actually has 6 conductors, not just the 2 lines, here called A and B. I'm not sure what all of them are used for, but 2 of them at least form a loop back to the wall outlet. That way you could have a priority phone socket and a secondary one for modems or fax machines. The phone would loop the AB line back when it's on hook and break them open, thus physically taking over the line when off hook. With this setup, you really lost your internet if someone picked up the handset. Speaking of handset, the speaker and microphone are hefty by design. The handset needs to push down on the hook after all, and getting into it was a nightmare. Somebody thought it was a good idea to have a latch on the end opposite the cable. There is no way to push that in without either risking a stab wound or breaking the cable in the process. The dial pad is a discrete component. It could be replaced as a unit. Let's peek into it. Interesting design. 3D electronics. There is a microcontroller on it. This model has redial after all, and for that purpose it also contains a buffer battery. That orange block here, I checked. It measures 3.2 volts. I am getting some mad respect for these 1990s lithium batteries. Yikes! There is some serious dirt hanging around the keypad. Recapping. Now the capacitors here aren't the only thing that is a bit 3D. I didn't want to remove it, but underneath the socket of the microcontroller there are two DIP ICs. I guess it's the ROM for the firmware, since this model of controller doesn't seem to have a built-in ROM. The small chip next to it is just a DTMF tone generator. And a proper cleanup later, it's assembly time again. connecting all the wires according to the pictures I took before. If anybody out there has a schematic for this one, please let me know. And now to the big moment, trying the phone on the line simulator. Yes, I got a dial tone. Now to dial the second line. Nope, that doesn't seem to work right at all. Darn, did I break that dialing circuitry? I can hear something happening when I dial, but it doesn't seem to work properly. During the assembly, I set the jumper on the dial pad from pulse dial to tone dial. IWV is the German Impulswahlverfahren, so I thought maybe that part is broken in this unit. I put it back to pulse dial and tried again. To find out that some of the buttons didn't seem to work at all. And wait, why is 0 only pulsing once? That should pulse 10 times. Oh! In another show of things that can go wrong for this episode, I paid close attention to put in the keys in the correct order, but I managed to put the keypad in upside down. So when I dialed 0, I actually hit the 1 key. No wonder the line simulator got all sorts of confused. And now, yes, it works! Resetting to tone dial again and buttoning it up. A quick note about the button and key on the phone. In Austria, we had shared landlines. These were cheaper for the consumer since up to 4 neighbors would share a single line to the phone company office. To avoid people eavesdropping, you had to reserve the line before dialing. This was done with this button. If you didn't get a dial tone after pushing it, someone else was using the line. This modern keypad model added the key to add a lock position and most likely a child mode, where you can program in a single number that will be auto-dialed with any of the buttons. Since I don't have the manual for it anymore, I cannot really tell the details. Hold it! I did manage to find a scanned manual. Link in the description. And the replacement MOV did arrive just in time for the video editing. And for funsies, I dug out my old US robotics modem, connected it to the second port and dialed the phone. Yes! Success! And that's it for this episode. I should be able to get some of the other modem or phone related devices finished up and tested this year. Now that I have a test bench that has actual proper signaling, it should be a breeze. I hope you enjoyed this episode. See you next time! The two larger ones originally were also bolted to the PCB for mechanical rigidity. Dang it! Rigidity. Why is it that this word always reminds me of sandstorm?